Today's lesson is on Bayes' theorem. Bayes' theorem is used to calculate conditional probability based on all the ways that a condition might have occurred. The way we read this, if you remember from last class, the P stands for probability. So basically it means the probability of A happening given that we already know that E happened, that E was already a condition. So right here we would plug in the number for the probability that E happened, assuming we already know, or the other way around, I'm sorry, probability of some kind of event given that we know A happened. So here's an example of Bayes' theorem. Let's say we're talking about LC screens. LC screens are the kind of screen that are on a lot of TV screens are made from LCD, or phones. So let's say we got an LCD screen for a large cell phone company. Okay, they're outsourced to 3 different companies. And the reason you might have a couple different companies make the same part is in case there's problems. Maybe one of those has a problem with work stoppage. So all of a sudden that manufacturer can't provide anything. Well, we still have 2 other vendors that we can rely on. This was a serious problem 10 years ago. 10 years ago was when there was a tsunami in Japan that caused a nuclear power meltdown. So as a result, there are a lot of problems with parts that were coming from Japan. The car manufacturer Toyota had a hard time because they couldn't get a hold of parts, right? So if you had parts coming from different vendors in different parts of the world, it would make it easier for them to adjust. So let's say, for example, vendor A supplies 60% of the screens, okay, to the cell phone company. Okay, let's say we got vendor B. Vendor B supplies 30% of the screens, and vendor C, the smallest one, is supplying 10% of the screens. The quality control experts have found that of the screens made by vendor A, 0.7% of the screens made by vendor A are defective. All right, from very small percentage. Of screens made by vendor B, 1.4% of those screens made by vendor B are defective, and 1.9% of the ones made by vendor C are defective. So the ones from C are not as good a quality as A or B. If a cell phone was chosen at random and that LED screen was determined to be defective, what's the probability that that LCD screen was produced by vendor A? That's the example we're going to be using for Bayes' theorem. So just some notes. P stands for probability. Okay. D means it's defective. And A, B, and C are the 3 different companies that are providing those screens. The unknown that's going to be calculated, that we're going to calculate, is the probability of that something came from company A if we know that we have a defective screen. So this is what we're trying to solve for. All right, the probability that the screen is from A given that it is defective. So our known probabilities. Okay, we just said that the likelihood that it came from screen A is 60%, right? We said 60% of the screens came from A. We said 30% of the screens came from B, and we said 10% of the screens came from C, right? Those we already established. So here's our example for Bayes' theorem. First, we'll review the conditional probabilities that we know. This reads the probability that a screen is defective if it came from manufacturer A. Well, we know that the probability that it's defective if it came from A is 0.7%. That was given. That was on that other slide we just looked at. The probability given, probability that's defective given that it came from B is 1.4%, a little bit higher. And the probability that it's defective if it came from company C is 1.9%, a little bit higher also. All right, so continuing with our example of Bayes' theorem. So the probability that a part came from A if we know that it was defective, all right, is equal to the probability that it came from A. If you remember, that was 0.6, right? The chance it was defective is 0.6. All right, remember that's probability that it came from A is 0.6. I'm going to plug that same thing down here. All right, so it's 0.6 times the probability that it was defective, then it came from A. Now in A, the probability, or 0.07, if you remember, were defective, right? So that's 0.07. So right here, the probability that it was defective and came from A, we just said is 0.07, okay? So it's 0.6 times 0.07 over 0.6 times 0.07, okay? Now we need to fill in the rest of it. Plus, probability of B, that was, I believe, 0.3, 30%, right? And the number that were defective that came from B, I believe was this was 0.014, right? And this was 0.007. I'm sorry, 0.007. This is 0.007. Let me fix that. Because it was 1.014, 1.4%, 0.014. All right, and all that plus probability that came from C, which is 10% or 0.1, and the probability of defective ones coming from C was 0.019. So the formula looks really scary, but once we figure out what's what and plug it in, it's not so hard. Because there's a lot of repeats, right? Probability of A shows up twice. Probability of defective came from A shows up twice. All right, so essentially the probability that the screen is defective and came from A, that's what we have for the numerator, over the probability is defective from anywhere. So here we got defective from A, defective from B, defective from C. If we had 5 manufacturers, it would be defective from A plus defective from B plus defective from C plus defective from D plus defective from E. So we have to add up all of those that are defective onto the bottom. So plugging in those numbers, again, I just wrote them down. 0.6 times 0.007, remember I corrected myself, over 0.6 times 0.007, plus 0.3 times 0.014, and then plus 0.10 times 0.019. All right, we do the math, okay? And we plug it in, and we get 0.4078 or 40.78%. So what that means is, given given that we know a screen is defective, 40% chance was that it came from A. All right, in the next example, let's say a cell phone was chosen at random and the screen was defective. So we got a bad screen. What's the probability that it came from vendor B? Essentially, this is almost the same problem as before. All right, remember it was the probability it came from A divided by probability for all of them. Well, the numerator is still the same. The only thing that's changing is the denominator is still the same. The only thing that's changing is the numerator, okay? So again, it's calculated the same as it is for vendor A. The denominator is the same. The probability effective by B is what's changed on this top. And the last problem, if a cell phone was was chosen at random and we found we have a defective screen, what's the probability it was defective? Again, it's the same formula. The only thing that's changing is the numerator because the denominator is exactly the same.